Good morning, everyone. I'm Shravan Kumar from Delsoft Technologies Private Limited, New Delhi. Welcome you all to this one-day online faculty development program slash workshop on circuit simulation and PCB designing. Delsoft, established in 2004, is a research-based company engaged in promoting path-breaking software solutions primarily for the education sector, thereby helping the institutes to enhance their infrastructure and provide best possible software solutions. So we try to conduct these kind of online sessions to aware faculties and researchers about latest technologies and related software to them. In continuation of this, we have organized today's session. First of all, we will have an introduction to Target 3001 software for circuit simulation and PCB designing. Then we will design and analyze an analog circuit and see full functionality of the software. After this, we'll design a digital example, see its input modification, output, and result analysis. We'll keep your mics on muted mode just to avoid voice interference during this session. And at any time or end of the session, you can write your question in the chat box given in the panel. After the session, we'll try to answer all your questions one by one. So once again, welcome you all to this one-day online FDP come workshop session on circuit simulation and PCB designing. We believe that the session would be informative. We'll have a 15-minute short break after the presentation. After this, we'll conduct an hands-on session so that you can work on the software along with this. For this, we have already sent you the link for downloading the setup of the software. We hope you have installed it already. After the session, please don't forget to send us your feedback and suggestion by email so that we can work upon them and improve it better. So let's start our presentation. So this is Target 3001, which is a SPICE-based circuit simulation and integrated PCB design software used in various industries and technical institutes for PCB manufacturing and lab curriculum. Now, introduction on circuit simulation techniques. So as we know, traditionally in 50s and 60s, we were using breadboards for designing circuits and hardware measurement unit for analysis of the circuits. Then ICs came into picture, but that was also not useful as there were many parameters attached to it. Like the commercial pressure as time to market devices was very high, and technically also there were some issues as many calculations were involved there, and doing so much calculation manually was not an easy task. So we require these kind of circuits in a simulation tool. Now SPICE. SPICE stands for Simulation Program with Integrated Circuit Emphasis, and it is a general purpose circuit simulation program for nonlinear DC, nonlinear transient, and linear AC analysis. This programming is done for every circuits in the backend libraries. Previously, when we don't have the GUI interface, we used to do circuit analysis by writing this SPICE programming only. Now circuits here can contain various devices that are available in the libraries like resistor, capacitor, inductor, independent and dependent voltage and current sources. Then some common semiconductor devices like BJT, JET, MOSFET, etc. is there. Some basic analysis is common available like DC analysis, transient analysis, and frequency analysis. Now this is environment introduction of Target 3001, where you will find this menu bar in which various options are available. First needed option here to create new circuit is component browser. This is component browser. It is there to import components. Then for conversion of schematic to PCB can be done through this go to PCB view, this one. This is for circuit creation, finding the components, and this is creating the PCB through the schematic diagram you have already created. Then some common options are available here, which is available in most of the menu bars of the softwares, like create new project, open existing project, open demo project, save project, zoom, copy, paste, etc. So this is the environment introduction for Target 3001, which you will find in the software when you start. I'll show you in software when we do the hands-on. Now, working on these kind of softwares is divided into three parts mainly. First is schematic, second is simulation, and third is layout. So first, you will create your design in schematic. Here, we can import components from libraries and create circuits, then set the parameters of component, and we simulate our circuit. Then in simulation, we simulate our circuit and analyze it by having different parameters, time domain, frequency domain, various analysis. Then in layout, we convert our schematic diagram to PCB layout, or we can make layout directly. Apart from this, it has another part of manufacturing where it has compatibility to generate file formats of various CAM or CNC machine to make PCB through those machines directly. Also, it generates Gerber data or GER file to make the PCB manually through the steps of machines, setups of machines we usually have in our labs. So, apart from these three main parts, schematic, simulation, and layout, we have another part of manufacturing in this software where it generates the manufacturing data for production processes. Now schematic, first part. Schematic design is nothing but a sketch of an electrical logic containing electrical connections between component symbols with the use of signal wires. You can see in the screenshot there is an example of schematic made in Target 3001 using components from the libraries and signal wires. Target 3001 has 36,000 plus components already in the libraries, which can be updated online as they get updated in the server there in the Germany. These components get updated in a month in the server. So whenever you are connected through internet, you can update it from the options provided in the component database that I'll show you in the software part. It has also component management and creation system where you can create your own components by using sample templates provided, or you can create your own component by giving proper parameters and spice codes. Now simulation. Simulation can be of two types. One is analog and other is digital. Also mixed mode simulation is there, which is a combination of both analog and digital. Analysis is having DC sweep, AC sweep, and transient, and probes are also there, getting the values of voltage and current at a particular point at signals. Virtual oscilloscope is provided for graphical view and analysis. Then graph calculator is there to calculate various other values of signals like log, exponential, derivative, integral, RMS, etc. Now after the simulation, we create layout of this circuit. So there are some integrated tools available in the software to create your design in an optimized place and optimized components. So first integrated tool is AutoPlacer. AutoPlacer is an integrated application which acts just before the conversion of schematic to PCB, which places the components onto the PCB in an optimized space. As we know, when we create a circuit in schematic, it's just a rough sketch of a circuit, but if we are going it to convert it into the PCB, that has to be in an optimized space. That's why this tool is integrated into Target 3001 to give you most optimized PCB. In the screenshot, you can see the auto placer where we have to set some of the parameters and you can start the auto placing. Now, as the auto placer optimizes the component, auto router optimizes the signals in a PCB layout. There are three types of auto router here: hybrid, counter, and an external auto router, Electra. You can use any of the available auto routing tools according to complexity of your circuit. Mainly we use hybrid and counter. It has some variable options that you can change, like signal length, drill hole diameter, algorithm, and routing layers. So in this screenshot, you can see in the actions we found the auto routing tools: Electra, hybrid, and counter auto router. Now this is the PCB which is made after converting it from schematic to layout, which is having the auto placed components and auto routed signal in it. Up to 100 layers you can make PCB. .t3001 file extension is made after the circuit is created and is widely accepted to make PCBs. Now this is 3D view of a PCB which is made after layout is completed. It will give you a look of your PCB made in real time. It has some features of customizing view of PCB, signal, layers, and package, which is given to analyze the circuit after PCB layout has been made. Now you can also do the EMC analysis check, which can be done after the PCB layout is generated, where we can see electric and magnetic field intensity in a circuit having different parameters like radiation coupling, galvanic coupling, track length, inductive coupling, and coupling factors. Now, before moving on to the PCB manufacturing part, let's design and simulate a simple circuit of half-wave rectifier to get the flow of working on the software. You can note down the steps here also that help you in the hands-on session. I also attach an hands-on manual after the break that you can also use. So this is the environment of the software. This is the workspace where you can drag and drop the components. This is the menu bar that I've already shown you, environment introduction. So this is the component database. You can click here and you can get the components. Okay. So these are the components which are characterized here in the name which we study and we know by their names, like capacitor, connectors, converters, diode, embedded controller, okay, inductor, logic, memory, microcontroller, microprocessor, operational amplifier, optoelectronics, relays, resistor, sensor, thyristor, transistor. All the components which we require in creating our circuit is available here. So let's say if you are clicking on capacitor, you will get options of having the bipolar capacitor, electrolytic capacitor, filter, trimmer. So if you click on bipolar capacitor, you will get bipolar capacitor. So these are the types of bipolar capacitor we have. You can click on any of the component and you will get the information regarding this. So first you will have the manufacturer information, package information. Then you will have the bipolar capacitor information having capacity, nominal voltage. Then in view you can have the schematic view of the component. Then you will have the package view of the component. And this is the 3D view of the component. So these three views are available for the same component. Okay, and this is the detail of component. So if you require, you can just click here and click on import component, and component will be attached with your mouse. You can just place it here. By scrolling, you can zoom and zoom in out. And if you want to rotate it, you can just right click on the attach mode only. You can rotate your component. Okay. So this is how you can place your component. And this place where you can click and join your component. So this is the way to drop your components here and connect it. Okay. We'll show example to flow of the software. So let's go to the component database again. So we are having the bipolar capacitor here. Okay. So apart from this, we are having the parametrical search. if you click here, along with this bipolar capacitor, we will have a parametrical search for bipolar capacitor. So whichever component you select, you will have the parametrical search for that component. So here it is a capacitor, so you will have the parameters accordingly. Like you can search the components according to the capacity, according to nominal voltage, technology, tolerance, or if you have any keywords, you can search it. Manufacturer, specific component, distributor, simulation model, 3D model, okay, package type. All these parameters are defined here. You can search your component according to any of the parameters given here. Okay. Then after this, you can search your component by providing its name. Let's say we search for diode. We will have a diode available here, and all the related components to diodes are available here. So if you click here, you will get the information of the component. So these are the ways how we can search our component, right from the by directly from their name, their types, or we have the parametrical search. Then we can have write their name and search the component. Okay, this is the update tab. You can update your component directly from here. If you click any component which is updated in the server, it will get updated in your system. Okay. So this is how you can search your component. Now, apart from this, we are having the categorized view of the components here. Like these are the sources, ground, connector, resistor, capacitor, inductor, diodes, all the components which are in the categorized form here. If you want to directly have the sources, you just click here and you will get the sources available here. Okay. All the sources which are listed in the software will be here. Okay. Likewise, you can search any of the component type, resistor, capacitor, inductor. You will click, you will have the direct search of that component. So let's select a sine wave voltage source and create a small circuit of half wave rectifier to see how we can work on the software. Okay, so we have placed a sine wave voltage here, and we require a half wave rectifier. So we directly drag this component, which is a rectifier diode only, 4148. So we directly drag this component and place here into the environment. After this, we require a resistor. We get the simulation model component only. So we'll get this 129.SMD bridge, which is a generic component for register. So we take this. We are having the DIN package and IEEE package. So we usually use the IEEE package of the component. So we click here and we'll get the IEEE package. This is DIN package. This is IEEE package. So we click here. We'll get the details. So we import it and place here in the environment. Okay. Now we'll place one ground here. Now we can directly connect the components and simulate it. We'll get the result. But when we create the layout of the circuit, what happens? This voltage source is an external source in any circuit. So if you convert your circuit to the layout, you will get only these two components in the layout, not the voltage source. So your circuit would not be completed there in the layout. So what we can do here is we can connect a 2-pin socket. So let's search directly 1x2. So you will get 1x2 socket. Just rotate and place here in the environment. So now when we place the socket and connect the voltage source through this socket, we will have a socket here, and when we convert our schematic to layout, we'll have a place to connect our circuit in external in the socket. So our circuit would be completed in the layout having the socket in place with the sources. So now we'll connect this circuit to the place wire tab. The mouse, in the mouse, this wire is attached, and in the at the end of the components you can see a cross wire on all the components. So with the cross wires we have to attach this. So when you take this mouse to the cross wires, a box will appear. So when box appears, you just have to click here and the wire will attach with your mouse. You have to connect this to this socket. Through this socket you have to connect the components. It is very easy to connect all this component. Just simply click and drop the source and destination. Now we have to connect the ground. Okay. Now the circuit is completed. Now we fill the parameters of the component. So all the components you are having this plus tab. Okay, all the components you are having the plus tab. So on clicking on this plus tab, you can get the component properties. Okay, so if you click here, you can get the value. So you can fill the value, let's say 12 volt given here as a voltage source. And if you want to change anything into the inside the component parameters, you can go to simulation values, then in edit, you can edit these components parameters like DC value, AC magnitude, AC phase, frequency you can change. By default this is 1K. So all these parameters which are defined here can be understood from this graph given here. From this graph these components are explained, what is the use of that component and what the value you can fill and see the changes in the circuit. So we go with the default. Then we'll change the resistor parameters. So let's say 300 ohm. We also set it for default for the diode. Okay. Now we have set up the circuit. One more thing we can do here is we can rename the signals, which is more useful when you design and analyze a bigger circuit and you want only the output to be performed in the oscilloscope. Then you can put a probe here and you can see the output of the circuit. So putting the probe, if you identify the signal by renaming it, it will be easy for you to get the probe. So let's say we are giving the output as out and input as in. So we can easily identify our in and out signal in any circuit. So as we have see that we work on the software in three parts. So first is schematic, simulation, and then layout. So first part we have completed here, that is schematic, where we have designed our circuit and fill up the parameters. Now we can go to the simulation and analyze our circuit. For this, you can click here and select start the simulation of the schematic, or directly F9 button is there, you can press it. Okay, so we'll get this simulation assistant where you will get the warnings and errors if you have. So if there is some warning, there is no issue, you can run your circuit. If it is red and C cross, then there will be serious errors. Then you can click here in the error and you will get what is the error is there and you can rectify. So we can give the parameters of simulation timing with 10 milliseconds here. You can start your simulation. Or if you go with the extended settings and you want to change something here, you can also change. So simulation end parameters begins with time, step at t is equal to 0, maximum step. So all these parameters you can define. And this transient analysis parameters is being explained here also through this graph. So with respect to time, we analyze the circuit here. So these are the vital parameters in every circuit. So if you want to change anything in your result, you can change the parameter of the component or you can change the component of the simulation parameters. So by changing any of the parameters, simulation parameters or component parameters, you can vary your result. So the result will depend upon these two parameters only. We can start our simulation directly. So by default transient analysis is there. So we'll get this oscilloscope window where you will have the result. So we are having V in, V out and I current is there. So these are the overlapping signals. So for seeing it clearly, you can go to the graph calculator. Here we can have the signals V in, V out. So if you click show none and see signals one by one, you can have V in signal first. That is 12 volt we have. Then we can see the V out. So in comparison of the output, we can see the input and output parameters. So if you want to have the output only, you can select V out. You can get the output only. So apart from this, we have the editor of analog graphs. You click here and you will get different parameters. You can calculate these parameters like ln value, exponential, log, 10x, dB, derivative, integral, maximum, minimum, RMS value. So all these value you can calculate for this signals we have. Let's say we are calculating the RMS value of V in signal. Okay, so if you click here, you will get the value 8.4847, and if you click OK, you will get the graph for the RMS value. So this is the graph for RMS value, 8.4847, something values there. Okay, so here you can change the color, pen type, pen width of the signals also. You can edit, delete, all options there. So likewise, you can calculate any of the value here. So this is analog circuit. So analog graph is there. If there is a digital circuit, a digital graph is also there. You can calculate the digital values. Okay. So we can close it. So apart from the transient analysis, we have some more analysis. Like in extended, if you click in commands, you can add some more analysis, transient, AC, DC, probes, all these functions are there. You can analyze. In probes, I will show you how you can use the probes. In select particular voltages and current, you click here. You can add voltage against ground, voltage against voltage, current, digital values, any value you can calculate. So let's say we select the voltage against ground. So voltmeter is attached with your mouse, this one. So if you want to have the output only, or in any circuit you want to have the output or any specific signal, just click the probe here and you can see signal V out is added. Okay, so if you click here, you will see V out signal is there, and if you close it and run, you will see only V out signal in graph calculator. Only V out signal is there. So this is for probing your signals when you have a specific value of the output. Okay. This is about the probes. So we have completed our second part also here, which is simulation. Now we'll go to our third part, which is layout. So for the circuit layout, this is a tab directly given here. Go to PCB view, or F3 tab is directly given here. So if you click here, you will see a PCB outline wizard where you can set the width and height of the PCB, or you can click on complete PCB outline, and that outline can be edited manually. So if you click here, you can see auto placer that we have shown you in the presentation also. So auto placer will start to optimize your components in an optimized space. So we can click here inside the PCB and place SMDs on top, and we can start. Okay. So this is your circuit, and PCB size is larger this, so we can just drag it and we can resize it to the required space. So this is your circuit. So here you can see why we have connected this 2-pin socket, because if it is not there, voltage source would not be there. So there is a place to connect a voltage source here now. So if we make a PCB from this circuit, we'll have a place to connect our voltage source. Okay. So now we have optimized the components. Now we can optimize the signals. This green signals you see. So for removing the short circuits and other disentangling between the circuits, we can uh, use the auto routing tool. So in actions, you can go for auto router and select any of the auto router. Let's say hybrid auto router is there. So in router, there are some options. In signals, there are some options like order of uh, tracking the signals, like route thick signal first, route short signal first. Okay, signal tracks we can define minimum track width, minimum track spacing. Vias we can define, either we can increase or decrease the use of vias. Okay, trivial diameters. So default parameters there to run the by default values. Then algorithm we can define. We can increase or decrease the disentangling between the signals. We can optimize your signals by increasing or decreasing the optimization values. Okay, you can increase or decrease the use of vias here. Route against the preferred direction of layer, we can use this. And we can use the route layers also here for routing layers. So we directly start a circuit. You can see we have auto routed the signals also. Now we can see its 3D view in view. And here you can see how our PCB is made when we create it. So we can see PCB in real time in the 3D view. So this is your 2-pin socket, this is your resistor, and this is your diode. So when we make a PCB in real time, it will look like this. So this is to realize how we can create our circuit and make the PCB. Okay. And these are the tools to see the components and package signals. So if we remove these packages, you can see your components one by one, D1, J1, R1. Okay. So this will help you in bigger circuit where components are located. You can see the location of the component. So this is how you can make the 3D view of any of the circuit. So for manufacturing, we can go for the manufacturing portion also. So one more thing we can see here is EMC analysis check. So start EMC check, calculate. You can see electric field intensity and magnetic field intensity of the circuit in the EMC check. Okay. So now, how to manufacture this PCB? We have completed the three parts, mainly what we usually have in the softwares: schematic, simulation, and layout. Now we'll move on to the fourth part we have in this software, or we can see this is the USP of the software, that manufacturing PCB is very easy here. So let's go to the presentation and see the manufacturing of the PCB. So for manufacturing the PCB, we have two methods. First is the manufacturing through CAM or CNC machines available in market. Target 3001 has interfaced with some of the renowned CNC machine companies for PCB manufacturing. The software creates the machine format for the PCB. So you can see in the screenshot, this is the output format. In this output format, we have all the CNC machines listed here. So you can create the machine data for any of the CNC machines, and you will send the file and they will get you the PCB design on the machine. Or there is a manual procedure of X Gerber. So second method is manual method, where software will give you GER or Gerber file, then it will give you a track layout. So you can see in the screenshot also there is this track layout. You can take a printout of this GER file on a glass sheet so that you can manufacture a PCB manually through the machine setup you usually have in our colleges. And this is the final track layout we get when we create a GER file manually. You can take a printout of this. It's okay. So in two ways we can see the manufacturing of the PCB. So before moving on to the digital designs, let's go to the software and see how we can get the manufacturing data through software. So on having this layout, you can click on the file, input output formats and production, then in engraving insulation channels. Here, after clicking here, you can get the production type, which is double-sided, copper top, copper bottom. Then you will have the output formats. So in output formats, you will get the machines listed here: CNC, HPGL, Isel, Proma, CNC, Charlie Robot, Colin Bus, LPKF. All these machines are interfaced with software. So you can get the output format of the software for this machine and send this machine data to these companies, and you will get the PCBs directly. Now we'll have to get the Gerber file for manufacturing the PCB manually in our labs. So we'll select the X Gerber for checking. Here many of the parameters are also defined, like diameter of the fiducial drills, okay, immersion depth, drill parameters, immersion depth of drills, immersion speed, copper top parameters, okay, copper bottom parameters, then PCB outline parameters. Here you can get the output file. So you have to select the output file. So let's select in the desktop and you can start creating the data. So data is created. You can click here and close it. So for getting the Gerber data, you have to open a fresh file of PCB outline. Okay. Here you can open your file. So in file, you can go to input output formats. Here in data exchange documentation, you can get the read xgerber and excellent files. Okay. So click here and you will get the read file option. In read file, you can click here and you can see in the desktop you are having the new.ger file. So this is your Gerber data ger file. You can open it. So here you can see this is the final track layout of your circuit which you have created, and this is the final data which will give you the manufacturing information, and this is how you can take the printout of this track layout and make your PCB manually in the machine setup. So this is how you can create a circuit right from the schematic, and then by checking it through the simulation whether it is working correctly. After this you will create the layout, and after the layout in an optimized space, optimized manner of the PCB. Then after this you can create your circuit in the real time also in the manufacturing portion. So this is the complete tool for creating any circuit right from the schematic to the final layout. And this is the complete flow of working on the software. So this is about the analog circuit we have created, and we got the layout data. Now we will see the digital design and see how the digital design is made. Now in digital design, there is a different approach to provide input and getting the output. We can use this stem symbol to provide input and SIG out symbol, which is a reference symbol, to get the output. Now in input parameters, when you click on the stem, double click on this, you will first see the simulation values window. So we click on simulation window, simulation values, you will get this window. You will click on edit, you will get the simulation editor, stimulus editor. So in stimulus editor, you have to click on this edit as a text, and when you click on edit as a text, you will get this window, spice stim as a text. So I just collected these screenshots here to show you how you can edit the text. So here in edit as a text, you can fill the values in zeros and ones and provide the input in binary. So time instant is provided here from 0 to onwards, 0, 1, 2, 3, 4. So on this time instant, we can give the binary values of zeros and ones. So when you fill these values in zeros and ones and save it, it will reflect in the waveform in low and high here. So we'll see in the software. Then in output parameter, you can get the SIG out from the reference symbols, and you can place it here in the output. So if you click here, you can rename it to some values, like we have used the full adder here. So we give this sum and carry to this SIG out. We are using full adder as an example here to show you how we can use the digital designs. So in full adder, we are using the XOR gate, two XOR gates, and two ICs 4081 and 4071. So we are using some parts of 4081 and 4071. So remaining parts also we can import. I'll show you how we can import it. So these are the three STEM symbols we have created here. ABC as an input, and this is sum and Cout as output. And this is your digital output, what you get after the simulation. So this is mixed mode simulation. So we'll get the digital output, and this is your analog output. So this is mixed mode simulation. So we'll see how we can design and simulate. So before moving further, we see the software and see how we can design and analyze a digital example. Okay. So this is your full adder where you have the two XOR gates, 4081 IC, 4071 IC for OR and AND. And this is the sum and Cout as the output symbols. Now we'll see how we can configure the STEM symbols. So for getting the STEM symbols, you have to go to the component database and write directly STIM. So you'll get STEM symbol, STIM, STEM clock, STEM hex. So all the symbols of STEM you get here. So this is a generic STEM symbol where you can give the inputs in binary. So you can import and place. So we are directly having the component, STEM component here. So we'll see how we can change the input parameters. So double click here, and in simulation values, you will get this window, and click the edit. Then you will get stimulus editor. In stimulus editor, you click here, then edit, and click on edit as a text. Okay, so in edit as a text, you can see in the waveform there is a time instant provided here, 0 1 2 3 4. So onwards time is given there. So on this time instant we have provided the zeros and ones input. So at 0 we have provided 0, at 1 we have given 1, 2 it is 1, 3 it is 0, and 4 it is 1. So we have given the time at time instant the input of 0 1 1 0 1. So you can see in the waveform also how it will reflect. So 0 to 1 it is 0, 1 to 2 it is high, that is 1, and 2 to 3 it is 1, it is high, and 3 to 4 it is 0, that is low, and 4 to onwards it is 1, that is high. So when we save it, this waveform will get saved, and this will be your input for STEM A. You click OK. And same as for the second B STEM, we'll have the 11011. Okay, so 11011. So we can save, and STEM C in the third one. You can add it stimulus editor, and add it as a text. You can see 01010. Okay, 01010. So this is the third input. Okay. Also we have edited sum and Cout. So we can directly simulate it and we'll get the result, but you will get some warnings here that you have not imported this components completely. That might show. So you can import those components, import rest symbol of the components here, and I'll show you after the simulation, because that doesn't require here. So we just directly simulate it and see the result. It will show you does not have a ground and some components are not model imported completely. So we can remove these warnings also. So before this we can simulate. So in the graph calculator, if you click here show all, you will get the output and input for digital also. So this is A, B, XOR1, C in sum. So more specifically, you can click on show none and see DA, DB, DC in, D sum and DC out. So these are the more specific values you require. That is A, B, C, three inputs, and sum and C out as output. You can verify it through the truth table whether it is correct or not. So it is according to the truth table of full adder only. So apart from this graph, we have analog graphs and digital graphs. Analog we have already seen. In editor, we have the NOR, AND, NOT, XOR, NAND, XOR. All the gates we can calculate in the graph. Okay, so this is about digital output. So now regarding this warnings. So we already know that 4081 4071 IC, we are using only the part of this component. Okay, because this is not the complete component. So when you import this component and import rest symbol of the components, you will get 4081 and 4071 ICs here. So click OK and you will get rest symbol of the component. You can place here in the environment. This is the power symbol. Now for 4071. Now it's empty. So this power symbol for this IC. So this is the complete IC that you have at 4071, and this is complete IC of 4081. But we do not require this component. But if you require, you can import it from the import rest symbol of the component. So when you put, let's say, a voltage source and a ground, you can connect the power symbol to this component. You can fill the values also. Let's say 5 volt. So we have provided the power to this ICs also. So now if you run, you will not get those warnings, but you will get the result. So for getting the result, we don't require full components to be imported. We will get the result as it is. This is how you can see the digital design. Okay. Apart from this, we have some demo projects also. When you install the software, you will have this demo projects with you. There are some simulation and PCB specific also. So if you click on dice PCB, you can have this circuit. You can get the PCB. You directly click here. You can also see the 3D view of the circuit. Okay. So this is the PCB, and this is the package that will help you to locate your component. IC2. K1, LED1, LED3. You can locate this component in the circuit. So this is how you can locate your component here. Likewise, you can have the circuits also. You can simulate this 7-segment display, and you can get the oscilloscope result also. And this is your interactive LED is there. So this is how you can design some more circuits, and you can use the already made demo projects which is there in the software. So let's go to our presentation part and finish it. So after the PCB layout, we can generate front panel layout of the circuit also by clicking on a single tab and setting some of the parameters given according to your requirement. Then we'll have a packet generator also. In packet generator, you can create your own components by selecting various templates provided there. You have to write spice codes there and set parameters. You can use default values by providing number of pins and size of the package also. 3D model of the component are also editable. So 36,000 plus components are already there in the library, and they also get updated time to time. And apart from this, if you want to have some components according to your requirement, you can generate it through the package generator and in the component creation wizard. Now this is a newly added feature, which is molded interconnect device or MID, which is an add-on module. With this, you can create layout on the PCB waste space left. So need not a flat PCB to create a layout. You can easily use your PCB waste in any shape. It has a design rule check also to get your components properly placed, and connection can also be checked properly. So you can make your design on the 3D bodies also, apart from the plain PCBs. Now here are some of the benefits of Target 3001. It has one project file for all the data. Like it has only one file, extension .t3001 file for schematic, simulation and layout. It need not create multiple files for different data. SQL component database for easier component search from library. Then it has a user-friendly licensing policy having no hardware locks, no activation codes, no node locking, and upgrades are also online, so no hassle for requesting your vendor for upgrades. Now my presentation is over. We'll have a 15-minute break, and after the break we'll have a hands-on session. So if you have already downloaded a software, you can install it, or if you are having the link on your mail, you can download and install meanwhile, so that you can have the hands-on session. I'm also attaching the hands-on manual right now, so that you can download the PDF file and also use the software after this session for your future use. So thank you. After 15 minutes, we'll gather again and we'll have a hands-on session. Now, welcome back, all of you. So, if you have already installed the software, so please be seated with your system. We'll have a hands-on session on the same experiment I've shown you. So, we'll see one by one how to import the components, how to create the circuits, how to analyze, how to create the layout and the manufacturing data. So, I'm showing you one by one. If you have any query, you can message me through the question box, or if I'm going very so fast, so you can stop me anywhere. You can ask me to repeat any step. And also, I have given you the handout manual. In the handout section, you can see there is a half-wave rectifier hands-on manual. This is the same experimental manual for half-wave rectifier, which is given as a step-by-step manual. So you can use that reference also. Okay, so when you open the software, you will get this window first. So you can create your components or create a new project through here, create a new project, and you can open an existing project from here. Okay, so you can click on create new project, and you will prompt this window where you can write the project name, file name, which is having the T3001 extension. Then you will have some options of single-sided PCB with schematic, single-sided PCB without schematic, then double-sided PCB with schematic, and double-sided PCB without schematic. So with and without schematic is when you click on with schematic, you can design your circuit through the schematic components we have. Then in without schematic, you can directly work on the package options. So you can directly drag and drop the packages and you can create your layout directly there. So we have to work on the schematic part. So we'll select this single-sided PCB with schematic. So this is the workspace. You can maximize it and we'll get the environment. This one. You can write your query in the question box if you have. Okay. So if you've got this environment window, you will get these menu bars here. Okay. Go to PCB view, zoom, fit to window, okay. Component search. So this is the first window you require, first tab, that is component database. You can click here and you will get this component database window where you can search your components. You can write the name of the component and you can search. You can have the parametrical search that I've already shown you in the presentation. I'm now selecting the component that we require only. You can browse it when you require. You have the software, you can do it yourself. We just go to the component we require and see the hands-on only. There is one query that how to download the software. Ma'am, we have already sent you the mail. In the mail, you are having the link to download the software. There is a Google Drive link where we have uploaded the software directly. So you can click on the link and software will be downloaded directly. So many of the attendees have downloaded the software from there only, and they are doing the hands-on with us. So you can click on that link and download the software. There is a 5 minutes. Currently I'm having the hands-on. I can't use the mail. So you can see this, and I'll send you after this, and you can have the hands-on. Next Wednesday also there is a hands-on. You can come again there at. I'll see you the manual and the setup directly. So now we do the hands-on. So for this, we require some of the components. So here I have shown you that these are the categorized view of the component. Categorized view of the components, like we require sources. So click on the sources and you'll see the sources available here. So we require the sine wave voltage, the sinus. Click the V sinus tab here and you will get the import component. Just click on the import component. The component will get attached with your mouse. You can place anywhere in the environment like this. It will get attached with your mouse until you press escape. So press escape and you can zoom in to see it in a larger view. You can scroll your mouse to zoom in and zoom out. Okay, so we have placed one component, that is V sinus. So first component we require this. You can place it from the directly from the component voltage source. I'm just repeating, import component, and you can have the component placed here. Okay, now you require a rectifier diode. So there is a diode options here. So when you drag this diode tab, rectifier diode, so by default rectifier diode is there, 1N4148. You can see rectifier 114148. When you take the mouse here, you just click this and drag it here in the environment. This component will get placed here in the environment. Okay, so place this component here, 1N4148. After this, we require a resistor. So for resistor, just below the voltage source, there is a resistor tab. So if you click here, you will get directly the resistors. Okay. So also you will get the parametrical search. So in parametrical search, just click on simulation model. After clicking on simulation model, you will get your generic component, this SMD bridge. Then you can select the IEEE package. Then an IEEE is there. So select on IEEE and you will get this register. Just close this parametrical search and click here and import the register. Simulation model, IEEE package, import. Just place here in the environment. Okay, now you require one ground. So just besides the source, there is ground, reference symbol ground. So it is also by default when you drag and drop. So you just drag this component, just rotate it to the place and drag into the environment. So we have dropped 4 components. So also we have connected our voltage source through a 2-pin connector. So we require a 2-pin socket here. Just to have the place of connecting the voltage source in the layout, we require a 2-pin socket. I've already shown you why we require. So for this, just click on the connector. So many connectors are there. So directly search for 1x2, 1x2, right? 1x2, and you will get the 2-pin socket directly. So 1x2 socket is there. Just import. The connector is attached with your mouse. Just right click, it will get rotated, and you will get 2-pin socket here. Escape for the mouse view. Now we have imported all the components we require. Now place wire tab is there. Just besides the component browser, you have the place wire tab. So click on the place wire tab. Now wire is attached with your mouse, and we have the components here. So all the cross wires you can see at the end of the component, cross wires are there. So through these cross wires, we can connect our component. So when you take the mouse to these cross wires, a box will appear. This box appears. So just click on the box, and the wire is attached with your mouse. If you want to repeat any step, you can write me. I repeat for any step. So the wire is attached. Now we can connect through this connector and this connector through the diode. Now through diode you can connect resistor, and through the resistor to the connector. Then again you can close the circuit. This is how you can connect. And this ground also. Okay. You can click here to fit window. Now this is how you can make a circuit. Okay. So after this, we require to fill the parameters of these components. So for this plus tab you can see on any of the component is plus sign. Okay. So click on this plus sign, and you will get the properties result of component. So first you will have the values, where you can fill the value of the voltage. So you can fill any voltage. I fill 12 volt, and if you require to change the frequency, you can click here, simulation values, and add it. You can get the frequency also. So click OK. 12 volt is voltage source. Now for register, click here, and you will get the value right here, 300. So The value you can fill, the units are by default given here. So if you doesn't write anything, by default it will take the ohm. Also, you can double click on the diode and simulation values and add it. You can choose the default option and select OK. The diode simulation values, add it, and by default value. Click on default and OK. You have to simulate it for default values. Okay. Now you have filled the parameters. Now you can rename the signals also. Click on in signal and you can write in out. You can write out. In signal name, you can rename the signals. This is for in, signal name in. And this is for out, signal name out. Okay. Till now we have completed the schematic part where we have designed and configured the components. Okay. So after the configuring the schematic, we can go to the simulation part. So in simulation, just click here and click on start simulation, or you can press the F9 button directly to simulate your circuit. Okay, you will get this simulation assistant. You can give the simulation values. You can change simulation values also from here, extended settings. And you will get the warnings and errors here. So if you click on the start simulation on default values, you will get this oscilloscope window. Okay. So you can see the signals one by one in graph calculator. V in, V out, or V out. Any signal you can see by selecting it. Okay. And you can calculate the graph also. Like we have calculated the RMS value of V in signal. In the graph, you can see the signals. Select V in signal, and you can get the value. And if you click OK, you will get the graph. So here you can calculate the RMS value or any value. And in graphs, you can select the signals. So we have completed the second part of simulation also. Now we'll see how we can create the layout. By creating the layout, there is a tab of go to PCB view, this one. Okay. Just beside this, we have go to PCB view or F3 tab directly. Just click here and you will get PCB outline wizard. Okay. So you can fill width and height or directly click on PCB outline. So click on PCB outline, complete PCB outline, and you will get auto placer tab. In auto placer, you have to select inside the PCB and place SMDs on top. Okay, order of placing is defined. So you can select start directly. Inside the PCB is on top, at first, just start. And you will get the component placed here in the PCB. So you have to drag this PCB size. So if you are working first time, so just right click on your window and uncheck these two options if it is selected. Select entire component and select entire module. Just uncheck this like this. So if it is selected, the whole PCB size will move with your mouse, so you can't drag it. So if you are facing this problem, you can just uncheck these two options. Select entire component and select entire module. Just right click and uncheck these two options. Then only you can be able to drag this PCB size. Okay. So like we have created the auto placer, now you can see the auto router. So for auto routing, you have to select actions, auto router, and select any of the auto router. We select auto hybrid auto router. So these options can be changed or selected. Signals, algorithm, and route layers. Okay. Or we directly go with the default and start. So it is routed now, and you can see the 3D view. This is how you can make the 3D view of any circuit by creating the layout. Also, you can select the in actions, start EMC check and see the EMC analysis also. Start EMC check, select all and calculate. Do you want to recalculate the result? We see yes. And you can see the EMC analysis, electromagnetic check, electric field intensity and magnetic field intensity. Okay. This is how we can calculate EMC. Now we have completed schematic simulation and the layout, third part. Now if you want to manufacture the PCB, that CNC CAM machines format you can create, or you can create it through the manual procedure and the GER file. So we'll see the GER method because we want to create the PCB through the GER method only in our labs. But the setup we have manual setup in our colleges. We'll go with the second procedure only. So for this, you have to go for file, input output formats, production, and engraving insulation channels. So see this option. I'll just hold on this screen. And these all screenshots I have included in my hands-on manual. You can see that manual and work your own when you have time to design any circuit. So you have the software and you have the manual. You can directly design your circuit. And if you have any other design, you can search in the company database and create your circuit. Okay. So these options have to select input output format, production, and engraving insulation channels. Just click here and you will get this window where you will have the production type, copper bottom, copper top, double sided. You select the copper top only. Output format, we are already having X Gerber for checking, and the other all for CNC and CAM machines format. So we select the X Gerber for checking, and these are other parameters we did not define, they are by default given here. And if you require, you can change. In start output, you have to give the path. I've given the desktop. So just click on start, and the data is created. Click OK and close it. After this, we can see our file here also. This is the PCB outline wizard, but it will show you overlapping this circuit. So we'll open an single side PCB without schematic option and get a fresh PCB outline wizard here. So click on complete PCB outline. We'll get a fresh window. Here we can open our GER file which is created. So go with file, input output formats, data exchange documentation, and read Xgerber and Excel files. I hold on this screen. You can check input output formats, data exchange documentation, and read Xgerber and Excel files. Okay, so click here and we'll get this window. Here you have to read that file. So in read file, you can click on this arrow and open this GER file, new.ger. Just open it and we'll start. When you click on start, you will get this layout. This is the final track layout or GER file which is opened here, which you require to create a PCB. You take printout of this file on the glass sheet, you go with the procedure of the manual PCB manufacturing and create your PCB. So this is the final track layout that you get after creating a circuit. So through this software, you can design and analyze analog and digital circuits. You can create the schematic, have the simulation result, create your track layout, see the 3D view also, and you can get the manufacturing data also to create your PCB in the real time. So this is the working on the software. So you are having the software, we have sent you the manual also. You can work on the software. So those who are having the demo version of the software, this is not a complete software. This is a feature restricted software just to evaluate the software, what are the features are there. Some components are limited there. So you can design some of the basic circuits there. If you require a full version, you can contact us for the commercial details to get the license version of the software. And some of the existing clients of us are also joining this session, so they have the complete version of the software. They can use it. They are already having the manuals and all, and you can use the software. If you have not seen any part of the session today, we are having the session on every Wednesday at the same time. So you can join our session. Given on the same link, you can register for the session and join it. So I've done with my presentation and hands-on session. If you have any query, you can ask me by writing a question in the text box. Yeah, ma'am, I'll send you the link on your mail. If you've not got the link for the software, I'll send you. Now, please download the hands-on manual through this hands-out, half-wave rectifier hands-on manual. I'll send you the link to have the software. Okay, you've written all these steps, so it's good. Okay, fine, ma'am. I'll send you the link just after this session is over. I'll send you the link. So if you have any query, you can ask me by writing your question in the chat box. Or if you have any query further, in the screen I have the contact details. So you can mail me your query and you can call me also on this number. I hope it would be an informative session, and you have must have done the hands-on session also. I have recorded this session. If you require, I'll send you the hands-on session also. Hands-on session or the presentation in a video. You can download the video and see for a future reference for working on the software. So I'll send you the recorded session also. So we are having the software and the manual also. You can work. And if you want the full version, you can send us the inquiry for the commercial details. So do you have any query? You can ask me by writing your question in the chat box. And please send us your feedback and suggestion for improve us better in future. So today's session is over. The presentation in hands-on. So concluding my presentation, we have seen introduction of Target 3001 software introduction. We have seen how we can work on the software, the schematic simulation and layout. Then we've seen the manufacturing portion of the software where we can design the PCB in manufacturing options by two methods, having the CNC and CAM machines format. Also, we can have the Gerber data for the manual manufacturing of the PCB. Also, we have seen the hands-on session where you can work on the software. I've sent you the the manual of the hands-on session that you can use it for a future references. And you can download the software and use it. So in future, if you have any query, you can ask me by writing a question in this email address. You can call me. So thank you for attending today's session. We are having this session on every Wednesday in June. So you can go with the same link if you or any friends, colleagues want to join this session. They can use that link and register for the session we have. So thank you for joining today's session.